So today what we're going to do is we're going to cover 2.5, and it came at a perfect time. So 2.5 is all about exponential functions, and so I created this graph, and I wanted you to see a real-life example of an exponential function. So as we know, the coronavirus has affected, now they're saying, 179 different countries. It is a pneumonia type of virus. It's one that no human has had before until China introduced it to the world, and so that's why it's so different in, as far as the flu, because no one's had it before, so that they weren't prepared for, our human bodies were not prepared for fighting it. Anyway, I am not a doctor, but I just wanted to give you an example of an exponential function. So this is the vertical line of the function is the number of cases in the United States. So this is just the United States. So this is the number of cases. Down here, our x-axis is the dates. So on 1/22, so January 22nd, 2020, we had our first confirmed case of the coronavirus. Then on February 2nd, there were 8 cases. On February 15th, there were 15 cases. March 1st, the number jumped to 76. And then we go through, and we are now up to March 25th. So this is as of the 25th. We are now at 68,285 confirmed cases. So watch what happens with our graph. Here's our points. I'm going to do this in red, I believe. I hope I can. So we started at 0. Nope, it's not going to let me. We started at 0. We went to 1. Then we gradually climbed to 8. Again, gradual climb to 15. And then it starts climbing a little bit higher to 76. And then as of March 25th, we are at 6,285. So what happens is we have this slow growth, and then as time progresses, all of a sudden the numbers really start changing and they really start growing. This is what's considered exponential growth. So I couldn't find it again, but I had read one article where this particular virus grows exponentially by the number 3. So when you look at exponential growth, what's happening is if the growth index is 3, what that means is at 3, when time starts, 3 to the 0 power is 1. So anything to the 0 power is 1. Then one person spreads the virus to 3 people. So that's 3 to the first. Those 3 people spread the virus to 3 more people. So that's 3 squared. Now we have 9 cases. So you can see we went from 1 to 8 to 15 and so on. So if we have a spread index of 3, you can see the numbers really start growing. 3 to the third is 27. So again, those 9 people, each of those 9 people now spread to 3 more people, each one. Then 3 to the fourth is 81. 3 to the fifth is 243. So you can see the numbers are starting to grow and grow and grow. Let me grab my calculator. And as the number of days progresses, our value starts changing. And it starts changing fairly rapidly. So on day 10, day 5, we had 243 cases. Day 10, now we've just jumped to 59,049 cases. So that's the idea of exponential growth. As things progress, it starts out slow, and then it really takes off. Now, here's the good news. So on your, in your Canvas classroom on Pages, if you go to Pages and go to my 2.5 videos, I have this particular graph and I'm going to try and show it to you. So if you want to go to Pages and take a look at this, you can see this is the different countries. So the one in red, right, I can't do it backwards, right here, this is China. So you can see, you know how you keep hearing about flatten the curve? Well, this is the exponential growth. It hit a certain value. They started able to isolate people, and then it started flattening out. So the virus is going to go away. It will go away. It's just going to take time. That's all it is. It just takes time. So we have to just be patient. As the weather warms up, the viruses normally tend to go away. So I don't know if you can see it. Again, this is on Pages in your Canvas classroom. The black number is the United States. So again, we are in the process of continuing to grow. We have not started to flatten out yet, but it will get there. It will get there. And then these are the other countries that are, Italy is you know, still growing. And at this point, Italy, I believe, have 7,000 deaths so far. The other thing that I wanted to bring to your attention is we have some numbers, and some of our numbers, sorry, I'm off camera. Some of our numbers, as far as the number of deaths, sometimes it's very easy to get caught up in the emotion of it and the panic of it. But this is what I love about math. Math is very logical. Excuse me, the numbers don't lie. So these are my numbers based on a couple days ago. I know the numbers have gone up, so I'm going to use the new numbers. So if we have 68,285 cases, right now, I just heard this morning that the cases, the number of deaths just went above 1,000. So if we had 1,000 deaths, and we had a total of 68,285 cases, we have 0.015. What that means percent-wise is it's 1.5%. So I don't want to dismiss the number of deaths because it's horrible. It's very sad for the families that are going through this. But as far as a percentage of the people that are actually dying from the coronavirus, it's only 1.5%. What that tells me is 98.5% are probably going to recover. All right, now I say probably because we don't know how many of these are in critical care, but the percentage, the higher percentage, is people who have recovered. Okay, so I just wanted to kind of give you that before I get into the actual lesson. This is a real-life application of exponential functions. So if you ever hear or ever think, when am I ever going to use this? Well, here you go. Here's a real-life application. All right, next video, I'm going to start the actual lesson on 2.5.